Hi there, pre-calcers. I'm going to go over a couple of examples in these videos on how to sketch transformations of functions, at least one way of doing it. So we're going to look at this function f of x is equal to x squared. That's our parent function that's sketched over here on the left. And we're going to sketch this function g of x, which is written this way in function notation. Equivalent form would be down here, written as a more obvious quadratic function, but these are equivalent here. Now, what I'm going to do is show us how we can actually compute where particular points are going to be plotted for the transformed graph. So we're going to go through this function right here and just see how that would be done. So I'm going to start with the point 0, 0, and we're going to apply those transformations as I see them. So the first thing I notice is I have this negative 1/2 here. That's going to be modifying the output. That's going to be multiplying on the output of my function. So because it's changing the output, I'm going to modify the y coordinate, and I'm just going to multiply by negative 1/2 because I'm multiplying my function by negative 1/2. I'm just going to multiply the output here by negative 1/2. Now, I'm going to take the y coordinate here, which is 0. So in this case, that's not going to change it because I started with 0. But if I had a different value there, I would just multiply by negative 1/2. Okay, so next I notice I have this minus 3 right here that's being subtracted on the input. So because this minus 3 is happening to the input, I'm going to modify the x coordinate here because that's my input coordinate. Now with the horizontal transformations, it's a little bit tricky because we have to do the opposite of the sign that's there. So a minus 3 actually means I'm going to add 3 to the x coordinate. So I'm just going to take the x coordinate here and add 3 to it. So that's going to give me the coordinate pair 3, 0. And then finally, I see the minus 2 here at the end. And this is acting on the output of the function again. So this is going to be modifying the y coordinate. So I'm going to subtract 2 from the y coordinate here because I have the minus 2 on the output of my function. So that's going to subtract from the y coordinate, and that's at 3, negative 2 is going to be the coordinates at that point. Now, then I can go ahead and place my point on the graph right there. So if I just place that right there. Okay, so now if I apply the same 3 steps to some other points on my graph, I can obtain the rest of my graph here. So if I start with the point 2, 4, and I just multiply the y coordinate and negative 2, 4, I just multiply the y coordinates by negative 1/2. Those are going to become both negative 2. Then if I add 3 to the 2 x coordinates there, that's going to give me 5 and 1. And then if I subtract 2 from the y coordinates, those are going to both be negative 4. And I can plot those points over here as well. And the reason I like choosing these 2 points is I'm going to have the symmetry there. So if I go take a look at the function that I'm going to get here, I plotted it in blue. You can see I have the point 1, negative 4 right there, and 5, negative 4 right there. So that matches, and then you can use the symmetry, the axis of symmetry here to plot the rest of your graph. So that would be one way of sketching your transformations. So then finally, just a quick domain and range piece to this problem. The domain of any quadratic function is going to be all real numbers, and the domain or the range of this quadratic function is all real numbers less than or equal to, that should be a negative 2, less than or equal to negative 2. Okay, we're in the next video, I'm going to look at a function that is not a quadratic function, and we'll take a look at applying those same rules to something we're not as familiar with.